Morning. I'm audible to you guys. What happened to others? Okay. I'm not sure what happened to others. So anyway, your main syllabus is already finished, but I just want to give some extra important things. Okay, the first topic I want to explain you guys is the spanning tree, which is related to the graph. Am I audible to you guys clearly? Okay, Happy New Year. Okay. Eh, Let me share my screen first. Okay, the concept you should know is spanning tree. Okay, this is related to your graph. It's a very important concept. There are different algorithms, but this is just like initial level. Then in-depth concept of spanning tree you will get in fourth sem in design and analysis of algorithms. So I'm just giving you a bit preview. So what is a spanning tree? Okay, can you tell me what is undirected graph? What is undirected graph? What is undirected graph? The direction is not present. Yes, correct. Then what is connected graph? This connected graph. Connected graph is कौन सा बाबा किसने भी सर connecting into node are connected with each other. Okay, and S1 or link is present between two nodes. Yes, that's correct. Then another thing is what? No isolated node should be there. Okay. What is a complete graph? See, as per you, so the connected graph is what? A graph in which there will be always a path from a vertex to any other vertex, right? So what is a complete graph? What is complete graph? What is complete graph? Which each paragraph vertices is connected. Yes, that's correct. So can you tell me the difference? So what is the similarity in connected, connected and complete? What is the similarity? Since both are connected, that means what? It is possible to get from every vertex to every other vertex through a series of edge. Okay, that means all vertices are reachable in both cases. Okay, then all vertices in both graph have a degree at least one. Okay, the degree of each vertex should be at least one. Then both of the types are made of just exactly one part. Okay, then what are the differences? The difference is that all complete graphs are connected graphs, but not all connected graphs are the complete graph. Okay, so all complete graphs are connected. এই সেইদিনা পাৰ্টি কৰা তেনেকৈ আছে অ', ঠিক কৰিবই আছে। So all complete graphs are your connected graph, but all connected graphs are not complete. আহিছে slow নেকি? Okay, and what's the other difference? Can you guess? Can you guess what can be the other difference? This is the difference. Can you guess? See, it takes just only one edge to get from one vertex to any other vertex in a complete graph. But in case of connected graph, it may take more than one edge to get from one vertex to another. Okay, so in case of complete graph, what? From one to other one, to move from one vertex to another, it will take just one edge. But in case of connected, it can take many edges. Okay, so this one you can just write one edge from any vertex to any other. For what? Complete graph. And in case of connected graph, it may take just more than one edge. So more than one edge. In case of connected. And another is if your complete graph has n greater than one vertices for complete, if number of vertices is greater than one, then each vertex will have a degree n minus 1. N minus 1. And in case of connected graph, n has n vertices, a vertex may have any degree greater than or equal to 1. And for connected, if we have n number of vertices, or n vertices, degree is greater than equal to 1. Okay. So now what is spanning tree? Okay. We wanted to learn spanning tree, right? So spanning tree is what? It's a subgraph of an undirected connected graph. Okay. So your spanning tree, you can say it's undirected and it's connected. First is undirected and second is what did I say just now? Answer. It's connected or complete? Yes, correct. Ah, কি কলা? হেডফোন ইউজ কৰা নাই? নাই কৰা। এই দুটা এই দুটা কানেক্ট কৰিলা মানে হেডফোন আছে স্পিকাৰ নাই। অ হ'ব হ'ব Itu Bluetooth nya Bluetooth lagi accessory. Bisa.
Ini boy কেনেকে আছে
Ini ada ya?
ইয়াতে ৰেছপন্সটো
Kenapa apa? Đang ngồi kia hả? Bicara. Iya, okay, so your spanning tree is a subgraph of undirected connected graph which includes all the vertices of a graph with a minimum possible number of edges. Okay, so if a vertex is missed, then it is not a spanning tree. Okay, one is undirected, one is connected. That means third one is what? Includes all the vertices. With minimum possible number of edges. Okay, so then there is one equation also. If total number of spanning tree with n vertices, so for n vertices, the number of spanning tree you can create is n power n minus 2. N power n minus 2. Okay, so if you have like n equal to 4, so what is the possible maximum possible number of spanning tree? Maximum possible spanning tree, what is? Yes, correct, 16. It's 4 power 4 minus 2 and it's 60. Okay, so with 4 vertices you can create 16 spanning tree. Okay, so suppose you have a just simple okay, so if this is a simple your connected undirected graph, so the possible spanning tree one is like this. Okay, for these vertices, then one is um, okay. Then there are 16 possible ways. That means you can just add one here. You can also add okay. Just remember that you can just create like connect any of the vertices. Spanning tree is what you can create if total number is 4, then you can create like 16 spanning tree, and those spanning tree is just a subgraph of your main graph, and it has to include all the vertices of graph with minimum possible edges. Okay, so you can try out many different spanning tree widgets. Then with the help of this, you can also create minimum spanning tree. Okay, this is just a spanning tree example. There are for 4 vertices, there can be 16 possible ways. Then another term is minimum spanning tree. What is a minimum spanning tree? It's a spanning tree in which some of the weight of the edges is as minimum as possible. So if I say just normal spanning tree, it will be like undirected graph and connected graph. If I say minimum spanning tree, then all the edges must have some weight. Okay, minimum spanning tree is just that some of the weight of edges is as minimum as possible. Okay, okay. So let's just take same graph, and now I'm saying just name it A, B, C, and D, and the values are 4, 1, 2, and 5. Okay, this is your initial graph. So I'm just drawing some of the possible spanning tree. One can be your A, 2. What will be the sum for this particular graph? Spanning tree 4 plus 5 plus 2, 11. Okay, next suppose drawing another one. 1, 2, and 5. So what will be the sum for this one? 5 plus 2, 8. Next, for example, sum is 5, 1. So for this case, sum is 10. Let's just take another one. 2, and 2. And sum is, okay. So tell me which one is the minimum spanning tree. I have given you 4 spanning tree, and which one is the minimum spanning tree? Which one is the minimum spanning tree? Last one. Yes. The one with the sum 7. This one is your minimum, while the total weight for spanning tree is 7. So minimum spanning tree is the one spanning tree which will have the minimum weight for all the ages. Okay. Okay, I'll just keep it till here because after that, this is just a simple graph. Then there can be many different types of like complicated graph like this. In, sorry, can be any type of graph. It can be very complicated graph and all. And for all these graph, you can just make many different spanning trees. So there are different algorithms to find the minimum spanning tree. Okay. So to find the minimum spanning tree, there are two algorithms mainly. One is Wheels and one is Pascal's. Wheels and one is Pascal's. I won't go in details. You will get it in next semester. And Mala ma'am takes this subject, design analysis and algorithm, and she is really good in that. Okay, so this is the basic things I wanted to tell. So you can say spanning tree mainly used in computer network routing protocol. The computer network is another subject which you will get in next semester. Then there is cluster analysis and civil network planning. Everything is done by spanning tree. But yeah, it's not the only uses of spanning tree. Again, minimum spanning tree application, you can say to find path in a map. Okay, just like remember I gave you an example of Google map. So if you can just consider a whole city or whole country as a connected graph, then each state will be a different node, you can say. So you can find the minimum path in the map with the help of minimum spanning tree. Okay, again to design networks like telecommunication network, water supply and electrical grids, everything, if you take it as a graph data structure, then you can find a minimum spanning tree or you can utilize it. Okay, that's all about spanning tree. Okay, for a complete graph, if say there is n edges for a complete graph, if you have like a number of nodes, I guess I already mentioned it before. Not sure if I put it in slide last time. For n vertices, a complete graph will contain n into n minus 1 divided by 2 edges. Okay, so these equations are very important in terms of your any competitive exams and all. Okay, they sometimes ask what will be the number of connected complete graph if you have n vertices and so on. Okay, always see these formulas. It sometimes it's confusing, but it's better you remember this because for most of the cases those equations are very similar. Okay, for complete if a complete graph is given, I'm telling you there are four vertices, then the complete graph will contain just 4 into 4 minus 1 divided by 2 edges. Okay, so that's all. And all complete graph undirected yeah, it can be both directed and undirected, directed and undirected. But normally, if we say complete graph, initially by default, we just consider it as undirected. Okay. Then if I say digraph or complete digraph, then it will be a directed graph. Okay. But if I say complete graph, then by default, it will be uh, uh, undirected graph. Okay. But yeah, if someone gives you an whole graph, means this is also a complete graph. If I put directions, that one also will be a complete graph. But then I have to mention the diagram. Okay. So by default, complete graph, if I say, just think it as undirected graph. But it can be both. Okay. So what's our next class? Okay, yeah, your second sessional will start from 7, okay? 7, 8, 9. Oh, আজি sign বনাই ন?
আজি নহয় 31st এইখিনি ভিডিঅ' ডিচেম্বৰ মানে এইটো আজি এইটো জানুৱাৰী মাহত বনোৱা হয়
Oh, মানে মই মানে নাই ন? 31st আহিছেতো।
এটা কৰি দিব পাৰিব
ঠিক আছে।
তুমি সেইদিনাখন আপুনি এইটো লেবৰেটৰী সেইটো কৰিছে মানস ছাৰৰ নাম সেইটো ঘৰে ঘৰে আজি কৰি দিম দিয়ক লেব ইনচাৰ্জ মানস
Manav's disability. Uh, each second session is for all subjects. Okay, second session means all subjects. So mostly your whole timetable will be same as your first timetable, just that the means dates will be different. It will be like 7, 8, 9. Okay. Okay. I'm ending the meeting now. Thank you, everyone. Let me take attendance. Is graded. Okay. Okay. I'm ending the meeting now. Thanks.